In this lecture, we're going to revisit the stdvector container. And we are going to revisit it because what we have seen before didn't account for the fact that we can use this container with iterators. And that's one powerful way to use this container. So that's why we want to do this here. This container is going to provide fast item retrievals with the array index operator. So if you want to retrieve an element and use the data, this container is going to make that pretty easy. And this is something that is much common in containers. The main motivation you have to put data in a container is so that you can retrieve the data and use it in your C++ program. So this is a very, very useful container. And I use it as my default. And if it doesn't work as I want, I can look for other containers. But in 70% of the cases, this has been worked pretty well for me. Okay, so we can use this container to store collections of items. This is a sequence container, so it is going to put elements in some kind of order. And the stdvector container has memory locality, so if you have elements stored like this, they will be stored contiguously in memory. And you can use pointer arithmetic-like operations to move from one element to another. For example, you can increment the iterator to go from one element to another going forward. You can decrement the iterator to move from one element to another going backwards. You can do these kinds of things. Now, here are a few facts about stdvector. This is going to store elements contiguously in memory. It supports random access iterators. So we have access to array index operator. We also can go either forward or backwards in our collection. This is good for retrieving elements using the array index operator, so you can specify the index and you're going to get the element right away. In other words, you can say, I want the element at index 5, you're going to get it right away. You can say, I want the element at index 15, you're going to get it right away, and this is really cool. We also have the flexibility of adding elements from the back, and that's going to happen very fast. But inserting in the front or in the middle is going to be very expensive because you have to copy elements and move them around so that you have a slot where you can insert your element. So if you are inserting or removing elements in the middle, that's going to be very expensive if you use an stdvector container. But CPUs are getting pretty fast these days, so unless you are doing a very computational expensive operation, this is really not going to be a problem, but do your own experiment and see what works for you. Just like our box container class that we have built ourselves, the stdvector class is going to automatically grow in size if you put in more elements than the current capacity can hold. And it is a good default if you want to store elements in the collections. Now, to use this, you need to include the vector header. So let's look at a few examples of how we can use this. We can create a vector of integers and a vector of items, and we can really put in data like we do for other containers. This is nothing new now. And after we have the data n, we can print our collection and see that we have the data n. We have different ways to do element access. We can use the array index operator. We can use the add method. The add method is going to do bound checking. The array index operator is not going to do bound checking. So with the array index operator, if you go out of range, your code is going to silently fail and you might get undefined behavior. So you need to be aware of this. But the add method is going to throw an exception if you try to go out of range, and you can handle this exception and recover from this error in your C++ program. We also have a front method and a back method, and this is possible because we have reverse iterators. We have different kinds of iterators we can use. So we have forward iterators as you see here. We also have reverse iterators we can use to traverse our container backwards. If you increment a reverse iterator, it is going to move backwards in your collection. You need to keep this in mind. We also have methods we can use to query for the capacity of our collection. The same methods we have seen already. We can ask for the capacity. We can ask and see if our collection is empty. We can get the size, the maximum size. We can do all kinds of crazy things. It is possible to push to the back using the pushback method. It is possible to shrink to fit. And what this is going to do is remove the capacity that is not used in your collection. So it is going to make it so that the size is equal or very close to the capacity of your container to save on memory that you are not really using in your collection. It is possible to reserve memory slots to have more elements you can store in your collection. You can do something like this if you need to in your C++ application. We have the possibility to clear and remove all elements, and if we call our method here, we're going to see that the data is going to go away, and if we print our collection, we're going to see that it has become empty here, but we can put the data back in using this syntax here, and if we print our collection, we're going to see that the data here is going to show up. It is possible to insert, and this is going to do what we already know. The first thing we need to do is to come up with an iterator where we want to insert our data. So we can use this syntax here to say that we want the element at the second index or from the beginning plus 2 locations. We can say something like this. And if we insert, the element is going to go in front of the current location for this iterator here. One thing you should know is that this iterator is not going to move with our data, so it is going to keep pointing to the second location, even if the data at that location has moved. As a result of this insertion we have done here, you need to be aware of these things. We can in place, and this is going to do the same thing like insert, but it is going to build elements in place. So if it is a custom item, we will build items in place and add them to our collection here. So we can specify the iterator where we want to in place, and the data is going to go in front of this location. With the in place method, we have the ability to specify multiple items that we want to add in one go. So this is going to create an item for 45 and an item for 10 here, and it is going to insert them in front of this iterator here. This is something you need to be aware of. We can also erase just like we did for other containers. The first thing we need is to specify the iterator where we want to erase. So we can do something like this. We can also erase from range by specifying the beginning iterator and the end iterator, and anything in this range is going to go. But I can't remember if this range is inclusive, but we're going to see this when we hit Visual Studio Code in a minute. Or you can even go in the documentation and try to figure this out, because you won't really keep all these things in your mind. One day you're going to forget what you did today, and you can either try to run the code and see the behavior, or you can go back to the documentation and read the behavior of these methods in terms of the ranges and how they behave. It is possible to in place from the back, and we can add multiple elements. So this is going to add 10 and 10, 10 and 11, 10 and 12. This is going to do what we expect here. And this is possible again because we have the ability to add multiple elements in one go. You're going to see this when we hit Visual Studio Code in a minute. And in place back is really like specifying the end iterator and insert elements in front of that end iterator. So what we have on top here and what we have down here are going to have the same effect. This is the idea here. We can pop back and resize, and this is the example here. For example, we can print our collection. If we pop back, you're going to see that the element at the back is going to go. It is possible to also resize our collection. So if we resize to 11, we are going to expand our collection, and down here we're going to see that the size has gone up. We can also swap things up just like we saw for the other containers. All we have to do is call our swap method and swap these two things. What we had in one collection is going to go into another, and we can see that down here after we do our swap. Again, if you want an exhaustive list of things you can do with the stdvector, please come back to the documentation and read all these things. For now, I am going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is vector or stdvector. We're going to grab the code from our template files and put that in place. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This will give us our main CPP file that we can clean up and include vector, our container of interest. And we can remove what we don't need from the main function here. We will go in front of the main function and set up a simple item class that we will use to study how custom items can be stored in our vector container. If we go down, we're going to have an output stream operator, which is going to print this thing out on stdc out. We also have our print collection function that you are familiar with by now. Let's remove the left sidebar here, and we're going to go in main and put in all the code for this lecture here. If you want, you can get the code from the resource section of this lecture. For now, I am going to put everything in here, and we're going to try and see what is happening. And this is really nothing different from what we have seen before. The only difference is that we are using an stdvector container, which is very different from the list and the forward list containers we have seen in the two previous lectures. So I want you to be aware of this. stdvector is going to store elements contiguously in memory, and it is going to have a random access iterator, so we can use the array index operator and do all kinds of crazy things. Here we have a few examples of how we can create an stdvector. So we can put in the data just like we see here, and if we print the data, we're going to see it. We are going to build this and run it and follow the code as our program runs, and I think that's the best way to learn about these things. The build is good, so we can bring up our new terminal window, and let's clear and run Rooster. And if we go on top, we're going to have our code on creating collections. So if we go down here, we will create a vector of int and a vector of item, and we will print these pieces of data. If we print the data, we're going to see numbers here. That's going to be our thing. You see the data. If we print items, we're going to see the data here. The data is going to go from 6 all the way to 10. And this is what we have in our container here. This is really cool. We can also use different ways to access data in our collection. For example, we can use the array index operator to get the element at index 3. So 0, 1, 2, 3, the elements at index 3 is going to be the 4 here, and you can see that we have access to that. If we try to access the element at index 30, this is going to go outside our range. So in this case, we will get a 0, but it is possible to even get a crash because accessing an array out of its valid range is really going to give you undefined behavior. But if we use the at method, we're going to get an exception thrown, and we can handle this in our C++ program. If you want, you can uncomment this line, and you're going to see that the program is going to crash because we're not handling this exception here. We can also use the front and back methods, and that's going to give us the first element and the last element. And we can even use the data method to get a pointer to the underlying array that is wrapped by stdvector. So here we are dereferencing the pointer and doing pointer arithmetic to get to the third element. This is going to give us the same thing. So this syntax here is really ugly. I don't recommend it, but it is something you can do in your C++ program. We are learning, so I really have to try and give you all the possibilities. If we go down, we will see the possibility for iterators. We can use a forward iterator to print the data going forward. We can use a reverse iterator to print our data backwards, as we see down here. This is working just fine. If we go down, we're going to find different methods that can allow us to query for the capacity of our container. So for example, we can ask the size of our collection. If we look in our output here, we're going to see that we have 5 elements. The max size is this number here. The container is not empty, so this is going to give us a false. The capacity is 5 by now, but after we push back, we're going to see that the capacity is going to go to 10, so the container is going to be expanded behind the scenes. Let's go down and see things we are doing here. So after we push back, the capacity is going to be the 10 that we have here. It is also possible to shrink to fit. This is going to bring down the capacity to the number of elements we have in our collection. You can see that right here. But we can resize up by reserving more slots in our C++ program. And we can do that by using the reserve method here. You see that if we do this, the size is going to stay the same. So we have a 6 here. And the capacity is going to go up to 20 because that's what we asked for by reserving 20 slots in our collection here. This is something we can do in our C++ program. If we go down, we're going to find a bunch of modifiers. For example, we can clear our collection. If we do that, every single element is going to be deleted and the size is going to be 0. The capacity is going to stay the same, but we can reassign data in our collection just like we are doing right here, and this is going to put the data back in, and we will see the data right here. So if we go down, we see that we have the ability to insert elements in our collection. The first thing we do is find the location where we want to add elements. So we want to insert at the beginning iterator +2. This is going to point to the 30 here. But what I want you to know is that this iterator is going to keep pointing to the third element in the collection even after we add elements. So for example, here we have 10n, we have 20n, we have 30n, we have 40n, and we have 50n. I think this is the situation. We also have a 60n, and we will have our iterator pointing to the 30 here. So if we insert the 300 here, it is going to go between 20 and 30. It is going to go in front of 30. This is how these things work. So we will have 300 in front of 30. But this thing is going to move to the second position because this iterator here is not going to move. So we will end up with this iterator no longer pointing here. It is going to be pointing to 300, which is going to be in front of 30. And if we insert 400, the number 400 is going to go in front of 300 here. So we will end up with a situation like this. We will have 10 and 20, and we will go to 400. Then we're going to go to 300 and go all the way to the end. That's what we have right here. You need to be aware of the situation that this iterator is going to keep pointing to the same location. If you want to update it to follow these elements, you need to do that explicitly. But by default, it is going to keep pointing to the second location in our container here. This is the situation I want you to be aware of. Now, we also have the ability to in place. This is going to build an element in place and put it at the iterator that we specify. We will put that in front of that iterator to be exact. So if we go down here, we will find our in place code. So let's look at in place down below here. So we have a collection with 6, 7, 8, 9, 10. And what we want is to in place 45 and 10 at the location of beginning +2. So beginning +2 is going to be where 0, 1, 2. That's going to be pointing to this little guy. This is giving us 450 here because we have a constructor which is going to take two items and multiply them. Let's go to the top and show you that because this can be confusing to many people. This is the constructor here, and it is going to take the parameters and multiply them and store the result in our mvar member variable. That's why we have our 450 here placed in our collection. It is also possible to erase. So let's find the code to erase. We're going to find the location where we want to erase. That's going to be at the 4th slot in our collection. We're going to erase that and print the collection again. So let's do that. We will target the 4th element. So this is the beginning +1, +2, +3, +4. So we want to remove the value with 9 here. And you're going to see that it is gone by now. And if we go down and specify that we want to remove a range, the range is going to be from begin +1 up to begin +4. So let's go down and find this data. Begin +1 is going to be starting from the 7 here, +2, +3, +4. So we're going to remove everything all the way to value 10 here. And if we go in, we're going to see that we're going to remove inclusively from the beginning of the range, but the last element is not going to be included in what we remove. We can see this here that we didn't remove the 10. So this is the behavior. It is possible to also in place back. So if we do this, we will be creating items in place and putting them to the back of our container. This is going to add 100, 110, and 120. And if we look after in placing back, we will see that we have more data in our collection. So 110 and 120 and 100 here. So this is the data. We can pop back. So if we have our collection here and pop the back element, we're going to remove the 120 here. We can resize our collection. So this is going to show that after we resize, elements are going to be created by using the default constructor. So the default constructor is going to be called to construct all of the default initialized elements that we have in our collection. The only valid elements we have are 4 elements, but we're going to see that all the other elements are going to be initialized with 0, and we can see that right here. This is something you need to be aware of. It is also possible to swap data. So if we go down, we're going to find the code to swap. And let's see what we have. We have our items here, and this is going to contain all the junk that we just put in. Other items is going to contain 22, 33, and 44. And if we swap these things, we're going to see that items is going to contain 22, 33, and 44. And other items is going to contain the junk that we had in items. This is how you can swap things up in your C++ program. This is really all I had to share in this lecture, showing you a few things you can do with the stdvector container. This is not much more different than what we have seen for list or for the list, but the vector is going to be using a row array behind the scenes, and it is going to have random access iterators, and that's going to allow us to do things like using the array index operator to get access to elements very fast. We are going to stop here in this lecture. In the next one, we will revisit the std array container. Go ahead and finish up here and meet me there.